Hello, Richard Halverson here. This is ITS128, and this is the fourth video of spring 2021, and we are in chapter 2 of the Xi books. Let me share my screen. Okay. And so we are right here doing, let's see, we're in chapter 2. Next week is chapter 3. Okay, so we want to finish up chapter 2 today. And I think we did a couple of the lab activities last time, and we got up to like section 2.6 or something like that. So anyway, let me let's go to the textbook. Let's see. Wait. Oh, here is my. Oh, this was, I was watching the last video. Looks like we got up to section. Okay, we did finish 2.13. Okay. So in chapter 2, that's right. We finished arithmetic expressions, and we did driving costs. And so today I think I'd like to try to jam through the rest of this chapter. So let's start with chapter 6. Let's see, kind of remind ourselves where we left off. Okay, so we're just learning about the operators in expressions. And so you should know all that. You know about parentheses. Multiplication is done with an asterisk. Exponent is 2 asterisks, like, you know, and you can put a minus sign in front of a number or a variable, and it's minus. This is called the mod operator, and that's the remainder. You know, this slash is dividing, and then this is just the remainder. Okay, and then there's plus and minus, of course. All right, and then left to right. Right, so that's what we learned last time, and so what section 2.6 is about now is for Python, in Python and in any programming language, we have to write the whole expression on one line. Okay, so that's the tricky part. You have to write it all in one line. And you know, in mathematical expressions, there's like, if it's dividing, it's up, it's, you know, it's like it's two-dimensional. It goes up and down and left and right, and things can be over things. And so that's the hard part. And so, but the good news is it's not up to the programmer to come up with the correct mathematical equation. It's up to the mathematician or the engineer or the designer or whoever it is, the smart people, the people that know about the context of the problem that you're helping them solve. They have to make sure they get that equation right. You know, that's their job. And then your job is to take their equation and write it like a Python expression. So here's an example of where you're asking for a down payment number, and you're asking for a payments per month, and you're asking for a number of months, and this thing computes the total cost. So it's the down payment plus the payments per month times the number of months, obviously, right? So you have, you're paying $350 a month for 60 months, and you multiply that together, and that's the total amount. But there was also a down payment, okay? And then this thing prints it out. So this is asking you if you understand about operator precedence. And so would removing the parentheses yield the same result? Well, yes, it would, because it's going to do the multiplication before it does the addition anyway, because of operator precedence. Would using the two assignment statements below have yielded the same result? So first you multiply those two, and then you add it. Okay, you introduce this intermediate variable here, which is actually just this. Well, the first thing you're doing is that, and then that gets that, and then the second thing you do is do the addition. So yes, that would be the same. Good practice. Well, that's preference. I actually like scrunched up expressions. It takes up less space, but yeah, whatever. Okay, so there's these things called compound operators. And what this is the same as this, where you take the old value of age, you take the current value of age, and you add 1 to it, and that gives us a new value of age. And so basically we're adding 1 to age, and we get a new age. And here you're subtracting 1, and so you can express it this way. You know, so if it's this equals this and then something, you can just skip writing, you know, this part, and you put the plus sign right there, and then you just put the 1. So, okay, so, all right. And you don't put commas in numbers, of course. Okay, so this is write a single statement that computes the average. Well, the average is, okay, so this reads in a number, reads in another number, reads in another number, and you're supposed to write a statement, and the result is going to be this, and you want it to be the average of these three. Well, that's just AVG sales equals num sales 1 plus num sales 2 plus num sales 3 divided by 3. Except for it's not really that, because if we leave it this way, the first thing it's going to do is it's going to divide this by 3, because division has precedence over addition. So we want to do the additions first, then we want to do the division. So to enforce that, we put parentheses around what we wanted to do first. And so this will give us our correct answer. Okay. All right, here's another one where you're given this expression here, and you're supposed to write the Python version of that. And so this is, let me pop up my whiteboard here. And let me move this over here. And move this over here. And we want to, here, this is a better way of viewing it. It's the volume of the sphere, which is sphere volume. So let me just go like this. Sphere volume equals 4/3 pi r cubed. So that's the formula. And we have to make it be where, let's see, we want to divide the 4 and the 3 first, and then we multiply that by the pi. And then we want to do this thing first, the r times r to the third power. Okay, so really we want to do this right away. Actually, it doesn't really matter because it turns out algebraically it doesn't matter. And then, we want to make sure we do this before we do anything else. And then we can do where this is multiplied by this and this is multiplied by that. So we can just write that SV equals 4 divided by 3. That's the one thing. Multiply pi. Pi is 3. Do we actually say what? Oh, we have a variable pi here, pi. So let me pi times whatever this is. And so I think we should have an intermediate expression here, and it can be R3 equals R asterisk asterisk 3. So the variable is R3, and so we can do R3 here. Or we actually could just do the asterisk asterisk 3. Do you know why? Because in this expression, exponent has operator precedence over the multiplications. Okay, so in this statement here, it's going to first do the 4 divided by 3 because that's in parentheses, and then it's going to come along and it's going to do this one first. So it's going to take the r, it's going to take r times r times r cubed, and then after it gets that number, then it's going to do this multiplication and then this multiplication. So this is how we can write it. And let's see if that's right. After all that, after I made you sit through all that, I'm going to see if sphere volume equals 4 divided by 3 times pi times what's sphere? Oh, wait a second. Oh, okay. What's r? Oh, it's a sphere radius. It's this thing. Times sphere radius to the third power. I think that's right. I think that'll work. Let's see if it does run. Oh, yes. Very good. Okay. Let's see. One more here. See, this class goes till start at 1:30. Okay, we're only 15 minutes in. All right. So what's next? Acceleration of gravity. Compute the approximate acceleration of gravity for an object above the Earth's surface, assigning this the result. So we have this thing, and we're going to put an expression here. I'm going to copy this, copy, and I'm going to put it here, paste, and that's going to equal something. Oh, what is it going to equal? It's going to equal this. Okay. And G, okay, so I'm just going to copy this, and I'm going to paste it here. Okay, look at that. Okay, it's pretty close. G times a divided by D, to the asterisk power, asterisk power. All right. So let's see if this works. So the G is already defined, and the M is already defined, and this, we're dividing it by D squared, and this is that number. Okay, so let's see if this works. Oh, D was not defined. Oh, because it's this. It should be this. Okay. So anyway, you can fix that. All right. Those are, so you get the idea, Python expressions. Okay. In this section, we talk about this, what division is all about. In programming, there's more to division than just the 5 divided by 3 equals 5 divided by 2 equals 2.5, or whatever, because we have in programming, there are integers that sometimes you're dealing with integers, and sometimes you're dealing with numbers that can have decimal points. And it also turns out that it's very, very handy because of counting, because we do a lot of different kinds of counting in programming, to be able to work with just the remainder. We divide two numbers together and we get a remainder, and that's the number that we're looking for, okay, for various reasons. So they're dedicating a whole section to this. Division and modulo. Division is the actual, there's when you're dividing, there's the dividend and the divisor and the quotient and the remainder, right? So in this case, the dividend and the divisor and the quotient is 2. The quotient is 2, the remainder is 0. In this case, the dividend is 5, the divisor is 10, the quotient is 0, and the remainder is 5. And it ends up looking like this, whatever. Here, so there's a, in Python, you may not want you may only want the quotient part. Wait a minute, my terminology was incorrect before. A quotient is the integer, the whole number part, and the remainder is the what's left over, and it's going to be an integer between 0 and the divisor. Anyway, a double / division just gives you the quotient part and throws away the remainder part. So 5 / 10 is 0 because the integer part is 0. 5 / 2 is just 2 because it's really 2.5 if it were a single slash, but we throw away the 0.5 part when we're doing a double in integer division. All right. So this wants you to, what is it? So this error. You can't divide by 0. So the microprocessor will tell you if you're making that mistake. All right, now modulo is division, except for you throw away the quotient. You only keep the remainder. So 24 divided by 10 is 2.4, but in 24 divided by 10 is 2.4, but we only want the 4 part. We only want the remainder. It's 24 divided by 10 is 2, the quotient of 2 and the remainder of 4. because 2 times 4 is 2 times 10 is 20, and plus 4. So 50 divided by 50, 1 divided by 2 is well, 1 mod 2 is 1 because 1 divided by 2 is 0 with a remainder of 1. So this is a nice example on converting minutes to hours, not to hours and minutes. So the program below reads the number of minutes entered by the user and converts the number of minutes to hours and minutes. So here we have where, let's say you enter in 75, and let's run this and see what happens. And modify the code to work in reverse, where a user enters 2 numbers for hours and minutes, and it returns a total number of minutes. Okay, so so if you want to modify this, you don't really get any points for this. This is just a fun example. And I guess you would enter in hours and minutes. So I'm going to go int input, enter hours. And in fact, I'm going to ask the hours first. Then I'm going to ask the minutes. And I'm going to say that minutes remaining, and I'm not going to call it minutes remaining. I'm going to say minutes total equals hours plus hours times 60. So it's hours times 60 plus minutes equals minutes total. And I'm going to say total. And I'm going to make this say 1 hours and so minutes is 75 minutes. Yes. Okay. And so I'm going to say 1:15. 1 hours and 15 minutes equals 75 minutes. What do you think about that? All right, so this tests your understanding of modulo. It's going to be 1. This is going to be 8. This is going to be 6. So anyway, is this error? Yeah, so 1 integer divided by 2 is going to be 0. And so here you're asking for what's 100 mod 0. And so that, I think, is an error. I think. Yes. All right. Here's a challenge activity. How far are we going? We're going to 11. Okay. So here's a nice challenge activity where so what's 6 divided by 5 is what is 6 divided by 5? All right, 6 divided by 5 equals 1.2. 1.2, enter. All right, great. So anyway, you can do those. And here's some nice modulo examples. You can go through those. Computing change. Cashier distributes change using the maximum number of $5 bills followed by $1 bills. I'll write a statement that assigns num1s with the number of distributed $1 bills given amount to change. Hint, use modulo. So if you ask for the input's 19, what's the change for $19? It's 3 $5 bills and 1 $4 bill. So you want to do modulo 5. Oh, I'm supposed to figure out what the number of ones is. Well, there's a couple of ways we can do it. I mean, we can do the naive way would be something like num1s equals amount to change minus num5s times 5. This will give you the right answer, I think. That's funny, but that's not what they were looking for. What they were looking for is num1s equals mod 5. That's really what they were looking for. So the number of 5s is when you just do the integer division of 5, and then what's left over is the mod of 5. So this also gives you the right answer. All right, module basics. This has to do with if you're using more than one file, you have this import thing here, and so you have a program here called printname.py, and the way this program works is it imports this file or this program, this module, imports this module, and this names it's talking about this module, this names.py file, and inside names.py is these two statements. So these two, when this thing executes, these two statements execute. So now there's two variables. One's equal to Larry. The first is equal to Larry, and last is equal to David. And then so when this thing executes, we want to print Larry and we want to print David, but we have to put the module name in front of it to identify, what first we're talking about. And so, or basically where to look for first. So it's got to look over here. So it looks in this module, which is basically, you know, inside here. So this is how you do it. And then when you execute it, it ends up executing like this. So you can click and go through this. There's that. And then there's this thing. And then this thing runs, it does that. So anyway, you can do that one. All right. So this is where it explains about this, putting this at the beginning. Let's see, the module, when a module is imported, all the code in the module is immediately executed. Python programs often use a built-in special name called this to determine if the file was executed as a script by the programmer or if the file was imported by another module. And so if the value of this variable, it's a special variable, it's a special built-in variable, if it's equal to this special string, then we know that the file was executed as a script. In other words, some user typed in saying to execute it. And so, you know, we may have a program that looks like this. And when we just run this thing, then then this ends up being true. And these two statements then will also execute. But if we have another program like this, and we want to import this in, then, you know, then we do this. In this case, we do not want this part to print, okay? Because we're importing this into something else, into another program. So this will only run if we're actually running this program by itself. But if this program here is actually being imported into another program, okay, then this part will not run. Okay, so that's helpful if you're creating a module that you're going to let other programmers use or use in other programs, and you're testing it. You know, you put the test stuff down here, and you can leave it there, and then you know, you can use this as a module in other programs, and then this won't, you know, run. All right, so that's how that works. See, so you know, that's pretty important. Another important module is this math module, because that's got a bunch of math functions, and it kind of sits by itself. And so like if you want to find the square root of a number, for example, you import this module, and it's got a bunch of, you know, built-in methods, and one of them, for example, is square root. And so you say, you know, you want to use this module or this method inside this module, or this function inside this module here. And so if you want to figure out the square root of a number, you know, you can use this function. So, and there's a bunch of them in there. There's it was POW is power. So it's 2 to the power of 10, 2 to the 10th power. There's okay, these are all of them. Or no, these are a whole bunch of them. These are commonly used ones. We've seen square root, math.square root, and then there's math.ceiling. It rounds up, math.factorial, math.fmod, which is remainder of a division. Must be of a large numbers, so floating point numbers or something. Floating point sum, yes, okay. The function, the exponential function, there's power, arc cosine, and okay, and so on. So there's a bunch of them. So what's the final value of z? Well, z is a ceiling, so it'll be 3, I think. It's the roof. We round up, not round. It's not even round. It's whatever the ceiling of this is. So this is floor. So this is the bottom. So this is 2. Yeah, see. So this takes it takes the floor of the 4. This is going to be 4. 4 to the 2 power. 4 to the 4 squared is 8. No, 4 times 4 is 16. 4 to the second power is 16. All right. So anyway, you can do those. Math functions, this wants you to say what the square, okay, so yeah, right. So what's the square root of 16? It's 4. You gotta make sure you press that enter thing. Oh. Oh, poopity poop. 6.0. All right. Okay. Floating point absolute value of 1.2. It's not 1.2. Gee whiz, I don't know what it is. I didn't read the book. Duh. All right, well, anyway, you can do those. This is square root. So first you do the y minus x, and then you take the square root of the whole thing. See, so first you take the, this is a challenged activity. What am I supposed to do? My right code here? That's pretty cool. So it would be z equals math dot sqrt of y minus x. Wow, that's pretty cool. It's interesting. Okay. All right. Well, anyway, you can do those. Using math functions to calculate the distance between 2 points. Okay, so here again, it's you got all these inputs, x2, x1, y2, y1, and and you have the square root function, sqrt, and you want to compute whatever distance is, point distance. So you want something like, point distance equals math.sqrt of x2 minus x1, close parentheses, to the power of 2 plus y2 minus y1, close, the power of 2, close. So anyway, that's probably what the answer is. All right, what's next? Okay, this talks about how letters and numbers and characters other than numbers are represented. And there's this thing called the, well, it used to be called, okay, it's called Unicode. And characters are coded as numbers, 7 bits, so what is the decimal encoding of the left curly? Well, it's 123, it looks like. 123. See? All right. These escape sequences are other special characters. This is really, you mean the character which will go down to the next line. For \T, really you mean the tab character, which spaces it over. Here in a print statement, you're supposed to enclose what you're going to print in quotes, right? Well, what happens if you want to print some quotes? Well, you can use the \, here, which means, okay, I want to print. I want this to be part of the string and not ending the string. Same in this case. Or what happens if you actually want to have a \? Well, you can do a \, and then that's \. So anyway, that's what that's about. Important. Print statements. What's the program's output? Enter. Yeah. All right. So anyway, they're going to try to trick you with quotes and double quotes and so on, \ and stuff. All right. So that's that. Pretty good. Okay, this is kind of fun. You can read this. Okay, this can be scored in a particular way of downloading scores, but I don't download these scores, so just doing this exercise would probably just help you become a better programmer. Enter a 2-digit number into the input box and press the run button. Okay, what happens? Okay. Well, that's pretty cool. That's pretty cool. Anyway, all right, so I've got about 15 minutes left, and I was going to see. I think we're done with the textbook, and so we did this lab last time, and we ended by doing 2.13. So let's go to 2.14. All right, so we got these expressions here, and based on years, pounds, beats per minute, and time. output each of the floating point values is 2 digits. Okay. So we have this equation. So we want to calculate what the men's calories is, calories man and calories women. All right, well, I'm going to do this. I'm going to, do I need to have an input? I guess I do. All right, input, let's say age equals input. That's going to be years. Weight equals input. And heart rate equals input. And the last one is time equals input. And then let's see, let me just copy this down, copy this over here. And I'm going to say this is calories women. And this is going to be calories men. Right, calories man, woman. And I don't have these. Don't want this. I want to change this to times asterisk, 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 oops, asterisk, 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 okay, oh, asterisk, asterisk. Okay, so I got that, and then I want to print this. That and that, and I want, which one do I do first? Women first. Women first. And this is going to be calories woman and calories man. All right. I don't know if this is going to work. Let's see. Let me just try it. Let me put these numbers there. Copy. Paste. Okay, there are those numbers. Develop mode. Run program. Oh. Heart rate. Heart rate. Float. Can multiply sequence by non-int of type float. Int? Oh, all right. Well, I'm going to try this. Float. I'm just going to floatify all of them, even though when I input, I'm not going to put decimal points. And that way, every number is a floating point number. And when I multiply, everything's compatible. Let's see if this works. Run program. Well, what do you know? Well, anyway, that looks pretty good. What's the next one? All right, given 3 floating point numbers, output x to the power of z, x to the power of y to the power of z, and absolute value of x minus y, and the square root of x to the power of z. All right, and then you want to print it out. Okay. All right, so here's how I'm going to do this one. I'm going to be computing these 4 numbers. Copy. I'm going to first paste it right there, and I'm going to say this is equal to something, and this is equal to something, and this is, and so is this. And the first one is equal to, well, I have to input something first. Okay, let me just do that. X, y, z. X equals float input x, no, input. Y equals float input, and z equals float input. And now I can take these things, and so output x to the power of z, 1. Output x to the power of z, output x to the power of y to the power of z, the absolute value of x minus y, and the square root of x to the power of z. And then when I'm all done, I want to print those numbers out. Copy. And so x to the power of z is simply x z. I can use pow if I wanted to, but I don't need to. I don't think I need to. Okay, this is I'm not including math either, so I guess maybe I might have to include math. Let's see if this works. So this is y to the power of z, and this is x to the power of y to the power of z. And the absolute value, ABS, x minus y. I wonder if that's going to work. This is, I think I got to do this math. Square root, x to the power of z. Okay, so if I have the math in there, then I'm going to have to do this import math. Hope that works. Close that up. Let's see what this does. Oh, I got to put numbers in here. Let's see. Copy, paste, run program. Well, that was pretty easy. All right, what's next? 2.16 and 2.17, is that right? Oh no, 2.16 is the last one. Let's see. Well, why don't I leave this one for you? I think this one would be a good one to leave for you. All right, so, all you got to do is you're going to have a statement here. And this is going to be R to the that. And so you're going to have R. And then you're going to have an F0 and an F1 and an F2 and F3 and F4. And F0 is has a frequency of F0 is, where does F0 come from? Okay, so F0 is input, must be input. So F0 is input. And it's going to be an integer. Integer is fine for this. Int. And F1 is F0 times R to the 1. F2 F2 is to the power of 2, to the power of 3, to the power of 4. So we have 4 is 4, you see, so F4 is F0 to the R to the 4th power, F3, and so on. So I think we can use the asterisk. I don't think I need to use POW. I think I can use this. And then I'm going to throw this out there. Oh, I got to compute. This is I think this is supposed to be F0, F1, F2, F3, F4. That's what I think. And so what happens if I put 440 here? All right. Well, anyway, so I hope so that pretty much finishes up chapters 2. And so next week I'm going to be doing chapter 3, and I'm not going to have 4 class periods. I may have 2. I would like you to go in and check off the times that you are able to attend a class, and go to the link is on the syllabus website, whenisgood.richhalverson.com or something like that. Anyway, thanks for watching, and I'll see you next week.